Okay, so here we're going to look at how we can find the zeros for this function. And so what I'm going to show you is I'm going to show you two different methods that we can use to solve this one. The first one's going to be familiar, and then the second one is going to show you a new technique. So for this first one here, I'm going to solve this by factoring. The first thing I'm going to do is I'm going to factor out that negative 5 because it's common in everything. So negative 5, I'm going to be left with x squared. If I factor negative 5 out of here, so divide this by negative 5, I'm going to get negative 2. And then if I divide this by negative 5, I'm going to get negative 3. And then that whole thing is equal to 0. Okay, so now I'm going to have to factor this. I need two numbers that add to negative 2 and multiply to negative 3. Well, if I think about it, two numbers that add to negative 2 and multiply to negative 3, sounds like that's going to be a negative 3 and a positive 1. Okay, so I can see right away that I'm going to get two solutions. X is equal to positive 3 and x is equal to negative 1. Okay. Now, if we remember the question here, the question on the previous slide says that we're looking at what time is that rock going to hit the ground. And so if you think about it, if you imagine, we're throwing a rock off a bridge here, it's going to fall and it's going to hit the water. So if you look at it, this part of the parabola really doesn't make any sense to us. This is before we throw the rock off the bridge, so this is not in our domain, but this one is. And so if I look at it, there's only one solution that could possibly make sense, and that's x is equal to 3 seconds. Okay, so it's going to take 3 seconds for that rock to hit the ground. Okay, so that's one way of solving it. That's using the factoring method. Now, I'm going to show you another method over here that's called the quadratic formula. The quadratic formula comes from looking at completing the square, and if you do it in general, you're going to come up with a single formula that's going to work no matter what, so you don't have to see what numbers add or multiply. If we use this formula, it's going to work absolutely every time. So if I have an equation with ax squared plus bx, c is equal to 0, so in this case a is negative 5, b is 10, c is 15. So if I have this equation equal to 0, then by completing the square, I'm going to find in general that I get this. X must be equal to the negative of b plus or minus the square root of b squared minus 4ac all over 2a. That may seem like a bit of a messy formula, but it actually allows us to solve these questions really easily. So now all I have to do is recognize what a, b, and c are. So here, a is negative 5, b is 10, and c is 15. So I'm going to plug those into my formula and let's see what we get. So x is equal to negative b, so negative 10, plus or minus the square root of 10 squared minus 4 times the negative 5 times 15 all over 2 times the negative 5. Okay, so now let's see what we get. That's equal to negative 10 plus or minus the square root of 100. That's going to be 20, that's going to be 300, so plus 300 all over negative 10. Okay, so again, that's going to give me a negative 10 plus or minus 20 all over negative 10. This gives us two solutions. That's going to be negative 10 plus 20 over negative 10, and negative 10 minus 20 over negative 10. Okay, so that's what the plus or minus means. It means there's two different solutions here. And so that I can see from here, that's going to give me, this will give me negative 1. So that would be negative 10 plus 20 would be 10 over negative 10, gives me negative 1. And then this one over here, negative 10 minus 20 is negative 30 over negative 10. And that gives me a positive 3 seconds. Okay, so I can see from here there's only one solution that could possibly make sense. Again, I'm looking at the positive solution for time, 3 seconds after it hits, or after it's thrown, is when it's going to hit the water. So we can use either method here. This one, of course, looks messy, but once you get some practice with it, you're going to see that this method is going to work every single time, and it's going to take some of the guesswork out of trying to figure out, okay, well, what numbers add or subtract to this, what do I have to factor out? less recognition here. This one's going to work absolutely every time.